Hello all, I'm Vidhi Parwanda and my team DeclinedCookies is here to present Medway, a software solution for optimizing appointment slot allocation across medical institutions. These are the topics that will be discussed in the next couple of minutes. The reason that motivated us to design a solution for this problem were the long waiting times that patients have to endure as they try to seek medical attention, while the hospital administration struggles to handle the huge numbers. It would be a lot more convenient for both the sides to have an automated appointment scheduling system that can significantly reduce the waiting time, thereby providing personalized healthcare to the patients and reducing administrative burden. It will also result in better utilization of the doctor's potential and time. Our approach to this problem is the use of genetic algorithm for time slot allocation and integration of an RFID system that can identify the presence of doctors in the hospital. These components of AI can be put to use to solve the problem stated earlier. As a further development to this, enhanced classification of patient profiles will be done so patients get allotted to the suitable specialist as identified by the mentioned symptoms. Moving on to the architecture of our system,
I'm going to take you through the overall architecture, hardware and server aspects of Medway. As we know, Medway is designed to smartly sense presence of doctors and optimally allocate appointment, resulting in substantially reduced waiting time for patients, also yielding maximum possible appointments per day. Let's dive into the inner workings of Medway. Firstly, we have an RFID check-in system. The doctor uses a unique RFID card, which is scanned using the system. It checks the doctor with the system. It senses presence of the doctor. Secondly, we have the server. The server is built upon a Django server with robust backend built using a lightweight SQLite database powered by a powerful Django ORM scheme, which is supplemented by a REST API framework and optimized Tailwind based frontend using vanilla JavaScript. Thirdly, we have a genetic algorithm. It is a scheduling algorithm which is optimally allocating appointment to the doctor in the waiting area based on the doctor availability, the patient waitlist, and the symptoms of the patient. Let's understand the flow of the system. First, a patient walks in. The receptionist fills in a web form which collects patient's name, contact symptoms, and previous history details. Then the form is submitted to the server and an appointment request is created. The genetic algorithm checks if there are any available doctors. If a doctor is available, the appointment is allocated. If all the doctors are occupied, the patient joins the waitlist. The doctor has access to a dashboard which displays information of his current and upcoming patients. This helps the doctor with informed decisioning. When the consultation is concluded, the doctor presses a send next button on his dashboard. This means requesting a patient. This again triggers the genetic algorithm to select the best fit patients for the upcoming slots and are allocated. The patient is flagged on the receptionist screen along with the notification to the patient which indicates that they need to proceed to the allocated doctor. The whole process is repeated until the doctor becomes unavailable or as the shift ends. Meanwhile, the patients can track their status on the dashboard. Moving on to the hardware. The hardware comprises of a robust Raspberry Pi based system with an RFID reader, an LCD display, and a 4x4 keypad. All the doctors are given an RFID card with unique ID. When they tap it on the sensor, it checks them in and displays a welcome message on the LCD. This action sends a post request to the backend, which updates their status to checked in. This is used to detect the presence of the doctor. In case a card is not working or available, the doctor can either enter their 4-digit PIN by pressing hash or replace their card with the admin team to get checked in. Doing the same process again checks out if already checked in. The system ensures a 5-minute minimum time period to avoid accidental checkout.
Coming to the front-end side, the tech stack used is HTML, Tailwind CSS, and vanilla JavaScript. There are separate logins provided for the receptionist and the patient. On the receptionist side, there are pages like Dashboard, Schedule, Appointments, and Appointment Form. On the dashboard, the receptionist can access various information such as available doctors, number of scheduled appointments, and similar information. On the appointments page, the receptionist can see all the scheduled appointments for today and can even view the past appointments. On the schedule page, the receptionist is provided with a Gantt chart where he can visualize the scheduled appointments and guide the patient accordingly. On the appointment form, there receptionist can add a new appointment. Natural language processing is used to determine the type of appointment and add it to the doctor's queue autonomously. On the patient side, there is a single page dashboard where patient can access his or her personal information. There is a section for updates where patient is updated for any changes in the appointment. These updates are also conveyed through the mail communication via backend server.
So for the backend part of our software, it is built on Django, a robust and reliable framework of the Python. In terms of data management, we have used SQLite as our database, which is BCNF normalized, ensuring data integrity and minimal redundancy. To guarantee secure user interaction, we have implemented Django authentication, adding an extra layer of protection to the system. For administrative purpose, we have developed an admin panel using Django built-in capabilities. This panel can be easily accessed and utilized by hospital authorities for configuring and managing information. Furthermore, we have incorporated a patient update feature prominently displayed on patient dashboard. This allows patients to stay informed about their appointments easily. To ensure prompt communication, we have integrated backend mail services for sending updates to patient via email.
Hello, so let's start with the genetic algorithm. Now, what is genetic algorithm? Basically we can say that it's a search heuristic method which is inspired by natural selection, and it is primarily used here for appointment scheduling. Now, what are the advantages of genetic algorithm and why have we specifically used it? It's mainly due to four reasons: optimization, flexibility, parallel exploration, and comparative advantage. Like comparative advantage, we can say that it is outperforming some simpler methods like FCFS and 3D heuristics. Optimization, it has a vast search space which optimizes patient wait times and doctor schedules. It's highly flexible, like we can add new patients or change the doctor availabilities. Parallel exploration, because it can simultaneously explore multiple solutions. Now let's talk about the working. Now it has 7 steps which you can see here: evaluation, initialization, selection, replacement, mutation, and crossover. Now the input of the algorithm is like we have a doctor matrix which is given, and it has the available slots and the requested patients, like what patients want to attend to which doctor. Now the output here is clearly seen here that we get the appointment matrix which gives us the preferred time, the appointment time, and the wait time. Now we can clearly see here that genetic algorithm is giving us the most minimal unscheduled patients and the most minimal waiting time. And this is what we can say it's a scheduling chart, or we can say simply a Gantt chart which schedules all the patients. Now, like coming to like why are we specifically using genetic algorithm once again? This all results justify that we can use genetic algorithm because it has shorter waiting time. It leads to fewer unscheduled patients, and it is inherently versatile, adaptable, and it's suited for environments with a lot of frequent changes. Like we can say that some cancellation of doctor's appointment at the last point due to, we can say, doctor emergencies or last minute cancellations, or some addition of patients like emergency patients, that can be done in here easily. And like genetic algorithm has, we can say, a penalty system that can incorporate hard constraints that the waiting time should not be more than 1 hour, or the number of unscheduled patients cannot be more than 5, making it adaptable to patients which have some sort of, we can say, non-negotiable time preferences. So hence we conclude that genetic algorithm that is used here, it is the currently most effective. I cannot say that it's the most effective, but we can say it's one of the most effective solutions that we can use for appointment scheduling.
Hello everyone, I'll be explaining the use cases and the market strategy for our product Medway. Medway is primarily designed for healthcare, with hospitals and clinics as our primary customers. However, the AI technology that we have incorporated for patient scheduling extends beyond healthcare. It offers a wide range of applications, from scheduling classes at a university to taking client calls at a service center. Now let's delve into market strategy and business model for Medway. Medway operates on a subscription basis. Medical institutions can subscribe annually, ensuring continuous support and access to the latest features. We are committed to providing regular updates that add substantial value to the Medway. What truly sets Medway apart is our unique selling proposition, the core AI technology. The core AI technology is beyond basic scheduling. It's about intelligent scheduling. Medway learns from past data, predicts demand, and optimizes schedules. In summary, Medway isn't just a software, it's a transformative tool with diverse applications and a robust market strategy. We are dedicated to making appointment management more efficient and pioneering a new era in scheduling. Thank you for your time, and now I'd like to walk you through the demonstration of our website. Upon entering the URL of our website, you will be redirected to the login and the sign up page where a new user can choose to sign up while an existing user can sign in. For the demonstration purposes, I'll be signing in as the receptionist. Upon signing in, you will be redirected to the dashboard where you can choose to add a doctor or add an appointment or view today's schedule or cancel and edit an appointment. Furthermore, you can also see the number of currently available doctors and the summary of the hospital. Now let's try adding an appointment. Upon clicking the add appointments, you will be redirected to the appointment form where you will have to fill in the patient details. After filling in the patient details, let's try and submit this form. After submitting the form, you will be redirected to the same form so that you have an option to choose to enter the details of another patient. Now let's look at today's appointments. These are the today's appointments and they are being scheduled by genetic algorithm. Now you can choose to edit or delete this appointment. You can also choose to export this to Excel or to PDF. Now let's look at today's calendar schedule. Upon clicking the schedule, you will be able to see today's schedule, and you can also choose to add a new appointment by clicking on the dates available from the calendar. You'll be able to see the doctors and the today's appointment schedule. Here, all the patients that are scheduled have been shown here. After finishing the work, you can choose to log out, and hence you will be redirected again to the login page. Thank you.